Lesson 12 is on the volume of spheres. So we've worked on right prisms, the volume of it, right? Rectangular and triangular prisms. We've worked on the volume of cylinders. We know they have two circular bases around them. We worked on the volume of cones. They have a circular base and then it comes to like a point. Now we're going to talk about a sphere. Now, a sphere, excuse me, it's a three-dimensional circle, right? We've seen globes or balls or anything like that. We know what a sphere is. So it says that the volume of a sphere can be found by using the formula 4/3 times pi times the radius cubed. That's different than what we've been dealing with, and I'll explain why. Now, it says if a cylinder and a sphere have the same radius and same height, okay? So the height, think about this here, right? If they have the same radius, r, and same height, the height of the sphere, now, remember, we're going from the top to the center and then to the bottom. This would be r to the circle here, the center, and this would be r. So the height of the sphere will be 2r. And the sphere will have, this one we're not going to try to figure out, but it's going to have 2/3 the volume of the cylinder. Okay, we're just going to go with that. Like a cone is 1/3 the volume of a cylinder, sphere is going to be 2/3 of it. Well, what happens, well, let's show you this here. Oh, you know what I forgot? Right here, before we move on. Half a sphere is called a hemisphere. We heard that word before, right? In geography. Okay, so we're just dealing with half, either top or bottom or one of the sides. It's a hemisphere. All right, so here is our formula for volume of a cylinder. We know that pi times the radius squared, I'm going to do better at that, times the height. Okay, that's the formula for the cylinder here, right? Now, the height, remember we said, is 2r. Because it's a radius now, two radiuses. It's a diameter, but we don't want to deal with diameter. We're not going to introduce a new variable into these formulas. They've all dealt with radius. So I'm going to replace the h with 2r. All right, now we're going to multiply it by 2/3, okay? So I'm going to go 2/3 times pi times the radius squared times 2, and that's actually times r, okay? And the reason I do this, I kind of wrote it out like that, is because this, with the exception of pi, these two numbers here we can multiply together, and we get on the top 2 times 2, which is 4, 3 times 1 on the bottom, which is 3. That took care of this and this. We're left with pi. And then notice we have r to the second, r to the first. Same base multiplying, we add the exponents. 2 plus 1 is 3. So that all gives us 4/3 pi r cubed. So it really is 2/3 of this, but when you simplify it, you get 4/3 pi r cubed. So now let's use that formula to find the volume of each of these spheres. Again, you can use 3.14. I tend to use pi key because it's more exact. Okay? Please write down the formula. Volume equals 4/3 times pi times our radius cubed. Okay? So in this case, you really only need to know the radius. So this is going to be 4/3 times pi times 3 cubed. Now we have to be really careful with this. I bring in my calculator here because there's different ways to plug it into calculator. But again, what I tend to do is I will go 3 to the third first. 3 times 3 times 3, or 3 raised to the third. No. Let me start over. 3 raised to the third equals. Okay, so that's 27. 3 to the third is 27. Now I'm going to multiply it by pi, and I'm just using the pi key. And now I'm going to multiply it by 4/3. Now you can multiply by 4 and then divide by 3, or you can go times and use parentheses. 4 divided by 3. And when you do that, we get about 113.01, or actually that goes to about 0.1, doesn't it? So this would be approximately 113.1, and I don't think they say what this is, so it's just cubic units, because again, volume is cubic units. Okay? All right, so now let's look at the next one. Start with the formula. Volume equals 4/3 pi times the radius cubed. Plug in the values. Well, don't just take whatever number is given here and plug it in. If the diameter all the way across is 12, then our radius is half of that. Our radius is 6. Try to be a little clearer. So that's the number we're going to plug in right here. 4/3 times pi times 6 to the third. Okay? Now let's see. Again, it's hard for me on my computer calculator, but let's see if I can type all of that in at once here. Okay, so what we can do is I can clear this out. Let's go 6 raised, nope, 6 raised to the third times 216 pi times, and then parenthesis, 4 divided by 3. Close parenthesis. Equals. And we get about 904 point, and again, it's not saying I don't think where to round to, no. So round it to like the nearest 10th or 100th even. This would be 904.7, just round it to 904.8. Again, as soon as we multiply by pi, it becomes irrational. So 904.8 cubic units. All right. So hopefully you're kind of getting the hang of this here, right? We always start with our formula. We plug in our values, okay, making sure that we have the radius for this formula. And we're going to replace r with 5 right now. And then when we use our calculator, that's what I want to do last time. I'm going to try this, okay? I'm going to go 4 divided by 3 in parentheses times pi. Notice I'm going just in order here. Oh, I didn't mean to enter, but that's okay. Times 5 to the third. And in this case, I get about 523.6 approximately, because we multiply by pi. Now, what you'll notice sometimes, guys, is you're going to have numbers that are a little off, but it's pretty close. And the reason for that, remember, is this said to use 3.14 for pi. Again, if you're using the pi key, there's a rounding error in using 3.14. So don't stress if you're really close, just off a little bit. Chances are either you or someone else used the pi key or 3.14. So just like we've been doing, get the formula. This time it's formula for the volume of a sphere. Plug in what you know. Use a calculator to solve for the solution.